Hi folks, so we've got Ciaran Kennedy here and
Laurent de Barry.
So we thought we'd have a quick history of market data and where market data has been used, the different architectures over the years. It's kind of ironic, when Laurent and I first met a number of years ago, we were having a number of beers and we kind of got into this whole discussion around market data, processing market data, how it's changed over the years, and more so where and if it was applicable for FPGA. And so really what we're going to do today is take you through that conversation with a little bit less drunkenness probably, and hopefully we'll be able to bring you through our thought process. Some of this we tried to keep it fairly vendor agnostic and talk about the platforms that are around at any particular time, and the architectures of those platforms, the years kind of, and where we think those things happen. They may vary a little bit based on each individual vendor's perspective, but we can kind of give it a good go of putting a kind of historical timeline together here.
And if I remember correctly, in that discussion, you called me crazy for doing market data on FPGAs, and now you joined me, so...
Now you're crazy for a whole bunch of other reasons.
All right.
So we'll kick off with 2001. We've kind of put some historical milestones of what was happening elsewhere in here so we can kind of keep context. 2001 was the year of the iPod, and back then market data was pretty much focused on vendor data feeds, multi-tier systems. You would have an exchange passing that data off to a vendor that would have multiple software hops in between, and then passing that off to a client. And what you'll see here is each of those little orange circles represents different software processes that more often than not the data would have to pass through before it would get to a trading application. In addition to that, most of this was over the good old TCP protocol, but then in the kind of later years of vendor data feeds, things like reliable multicast started to become a little bit more prevalent, which brought with it some challenges of its own as well.
And looking at this with the 2020 glasses that we have, like, what was the latency of this architecture? There's so many components on the chain.
I think the interesting thing is back then people weren't even measuring latency, so I'd hazard to guess it was 10 plus or tens of seconds as opposed to milliseconds or nanoseconds. And I think the other thing that was kind of key with these architectures was it could be different for each person. So one firm might have multiple different layers, or whatever path you were taking through the software at a particular time, it could be different. Also, didn't have the measurement tools we got today.
Okay.
All right, moving forward, 2004, when Google launched Gmail and folks started getting rid of their Yahoo and AOL addresses. And we found a nice, interesting article out there which kind of had Jeff Wells from Reuters saying that by next year, in 2004, we'll see 62,000 messages per second, and that was including listed NASDAQ and equity options market at US Market Open. So that was a crazy number at the time. And then we had that countered by Danny Moore from Wombat, who was one of the first software firms out there building market data solutions. And he was kind of countering that with at least 120,000 messages per second by November 2005. So I think what we're seeing is kind of a very clear doubling of rates in the market. And that was a quote by Danny Moore, but that's not what we call Moore's Law today. So looking at the architectures that were kind of born out of that era, 2004, we had a kind of collapsed architecture where many of those tiers you would have seen with vendor-based systems were removed, and actually the vendor-based layer was removed altogether. So folks were taking direct exchange feeds, and they were taking those directly into feed handlers, and those feed handlers were doing all the processing, the AB, arbitration, normalization, the distribution, and the caching all in a single platform.
And so we can see that from the previous slide, previous architecture, and now there's like so much less servers in between. What was that driven by cost, or was it driven by latency?
I think initially, while latency was always a driver, and the good old question of if you ask traders, do they want less latency, they're all going to say yes. Then you ask them who's going to pay, they'll say no. But I think really a lot of the driving factor here was just simplification and lowering of costs. So even on the end client side, you would have seen there was a multi-tier server architecture for the distribution part. So being able to collapse that was a huge win for many of these firms. And then this kind of progressed into using reliable multicast, which was interesting. So you had things like TIBCO Rendezvous, 29 West LBM, which allowed people to fan out a lot more efficiently than you would with TCP, which allowed you to keep those kind of single tier architectures. But they brought with them all of their own sorts of problems. Like, you've got a poor network, then you're going to have multicast storms.
Mm-hmm.
Okay, so moving forward, 2006, the year of the Wii that was sold out everywhere when it initially was launched. I think everyone can probably remember that. But what also happened that year in the trading world was firms started moving towards the idea of co-location. So no longer did we have this idea of, hey, you've got a data feed coming from Exchange to a vendor or directly to a client site. It was, hey, we're going to move everything towards the Exchange and co-locate directly with the Exchange. So that was a huge reduction in latency from the network data path or the WAN data path, but not much change to the overall architecture.
All right, so that means that now people were starting to measure latency because you would only do that for latency purposes, right?
Yeah, and co-location, always, even back then, was coming at a premium. So, you got to justify why you're doing that. And at that point, this is, I think, where a lot of the conversation turned to latency as opposed to kind of simplification of architecture.
And people dropped everything and moved everything to co-location, or how did that go about?
I think it's the kind of way that people approach that is a little bit differently to what they do today. I think now most stuff sits in co-location with kind of off-site backup, whereas back then it was, hey, most firms would have one or two huge primary sites which would take all the data feeds, and then for more strategic applications they'd move them directly towards co-location.
Okay, so low latency strategies to co-location, keep the rest there in your own data center for now.
Yep, that's what we kind of saw happen. All right, moving forward, 2007. 2007 was a huge year for technology in that the iPhone was out and things never really were the same after that. Also, when we look at kind of trading technology, a lot of things happened. A lot of this was kind of spawned by Reg NMS, which was a regulation here in the US which focused on kind of making sure you were looking at best price. That meant that many of these firms had to have access to data feeds from all the different exchanges and the SIP feeds. And also this drove kind of more activity towards the market and more messages per second outside, right through the whole system. So, a couple of quotes here. We've seen, if you look at January of 2007, the NSX was seeing 24,000 messages a second in June, whereas in the previous year it was 6,900. So that's a huge increase. And even Peter from Stack was quoted as saying that this data increase tends to mean more latency, which I think over the next handful of years was really where people started focusing on kind of disproving that fit theory and reducing the latency. This is the first time that Opera was out there also telling people to prepare for 1 million messages per second. So things were definitely starting to ramp up. A few of the key technologies. First one, kernel bypass. So kernel bypass was effectively the first use of hardware to kind of reduce the processing that needed to happen in a particular software process. And so really what firms were able to do was offload that network portion or offload part of that network portion to hardware in a PCIe card, and that allowed them to effectively reduce end-to-end the overall latency.
And I presume also doing more with the same hardware. If you have a kernel bypass card, your OS is not the bottleneck anymore, so you might be able to keep up with those increasing rates.
Yeah,
without having to throw more servers at it.
Yeah, and some of the idea behind that was that at that point with software you could only horizontally scale. Now you could horizontally scale and throw hardware at the problem, which meant you were kind of limiting how much horizontal scaling you had to do. Next, around 2007, there was the idea of software libraries, and so for very particular sets of applications, you ended up with a situation where you had a library you could embed directly in the application, which would allow you to process the market data. Obviously, coupling that with something like kernel bypass that we just talked about allowed you to do a lot more and cut out all of the layers of feed handling that you would have seen in a more traditional architecture.
Yeah, so if we look at the beginning, we had many servers to do this, then we went to one server doing one feed, and here we're starting to have multiple feed within one server, but you also know that in 2007 the rates are increasing, so how is that scaling? What are people doing then?
And I think what changed at this point was it then became about, hey, the only way to solve this problem is throw more servers at it. Okay. Because at that point you're looking at, hey, we've done what we can on kernel bypass, we've done what we can on making the software more efficient, and market data rates are still going up. So your only real option at that point was to throw more hardware at the problem.
So is that the first time in history where market data became to be a volume problem?
I think it was probably a little bit of a volume problem before this, but I think 2007 Reg NMS type time frame is when it really became something that people started to focus their attentions on as opposed to latency.
Okay.
Another kind of way that people were putting this same sort of model together was a lot of the feed handler vendors that were out there at the time then started to look at direct memory access. And you've got two different versions of that. You've got local direct memory access, where you cut out the whole network stack and a feed handler effectively writes to a memory buffer and the application reads from that. Or you've got the use of kind of cool technologies at the time like InfiniBand, which allowed you to write into a shared ring buffer and then multiple applications even read off that same buffer. Both were an idea of reduction of latency, but also because, again, a lot of that processing tended to be on the network side, they reduced the overall footprint of many Tickerplants.
So we basically had on the same year all those technologies come along to help with moving that amount of data around between services and between servers. And so that was basically just different vendors giving their own solution to the problem.
Yeah, and that was it. I think rates went up. Each vendor went out and said, hey, get our best guys together. What can we do here? And they each come up with different ways of putting that together. And then you kind of look at the idea of co-location and the fact that co-location was expensive. You couldn't just throw hardware at the problem, because then that started to have an exponential growth rate on your cost. And so what we saw at that point was some vendors starting to use a kind of hybrid approach of leveraging some hardware, possibly FPGA, possibly GPUs, along with software to kind of build these appliances that effectively would just sit in the rack and do all of the processing and then pass that out over something like a reliable multicast.
Yeah, I mean, that's not a surprise to me. Like, we just went through 10 slides of things that happened in 2007. It makes sense that some vendors would work to package it up, everything together into one server to try to ease the pain for end users. So you had the firms that would do their own thing, but you had a firm that could rely on those solutions to trade and cope with the data.
Yeah, and that I think at this point it was all a race for which vendor could get which technology out the quickest. And then you kind of bring all of that together, and you've got InfiniBand. And we talked about InfiniBand earlier, but pairing that with a vendor appliance made for kind of the best of all of those disparate pieces of technology that you could get at that particular time.
Yeah, InfiniBand was good at that time because it was just higher bandwidths than Ethernet. They also had RDMA, being able to send data through InfiniBand. We don't hear too much about it today, but that was big at that time.
Yeah, I think a lot of what I heard of the challenges with InfiniBand more came down to the fact that it operationally didn't have the tool set, the chain, the monitoring that you would have had with something like an Ethernet. All right, moving forward quickly, Tesla Roadster was out in 2008, and 2008 really was when everything started to change. We had Lehman Brothers, Merrill, AIG all having major problems. Bear Stearns shut its doors. And for the vendors of this world, the challenges became a little bit differently, because half your client base had disappeared overnight, and now no one's really looking at market data rates or latency. They're looking at staying alive. And so I think the kind of thought process of many firms at that point was just like, keep the lights on.
And so in 2011, that's when Enyx came about. So we started at a time where rates were increasing, everybody was really, really cost conscious and trying to do more with less. And so FPGA is a good technology for this. It's really, really tailored to deal with large amount of data and do it in a low latency fashion without having to throw many servers at a problem. So it came at a good time.
All right, and then 2013 hit, and I guess that's when we had the Facebook and Twitter IPOs. Again, huge market data events for this space, and also huge data rates. So you kind of see, and this is from a filing to the SEC on the SIP actual peak quote rates. Just for quotes on the SIP, this was went from 8,600 messages in 2006 right up to well over 500,000 in 2012, and then by midway through 2013 you were hitting the same rate. So clearly staying on track for those doubling of market data rates, more participants in the market, more activity in the market, and things are starting to look like they're recovering again.
And on top of this, these message rates were for layer 1 books, so It's even less messages now. We know that around that time, that's when you started to have layer 3 books where each order was sent. So the volume data was really, really growing exponentially. So talking about FPGA cards, so 2013, that's where we launched our feed handler solution called Enyx Feed, which is using FPGA to process that market data and hand it over to a software either locally or remotely through PCIe or Ethernet. We chose to use a card because it was going to be very flexible. You can deploy it directly into existing server, again, in the idea that you would not have to buy new servers to run those solutions. But if you had another solution with an appliance-based solution, you could still accelerate your appliance with those FPGA cards.
And so was part of the thought process here kind of similar to what you had with kernel bypass, in that rather than just doing the piece where you offload the network, you're offloading kind of all the market data processing?
Yeah, it's pushing that further. So the FPGA can decode, normalize, build the book, arbitrate, and do all this and pre-crunch that data and hand over fully digested data to the software. So that even push further what you can do with one server, because on the market data front, there's nothing left to do.
Yeah, okay, that definitely makes sense.
And so, as I mentioned, if you had firms with a Tickerplant approach where they really want to have one part in the network that's going to process all the market data and hand it over to the rest, again, you didn't have to throw everything out and start over. You can just update your Tickerplants with those FPGA card and have kind of a centralized FPGA-based processing of your market data.
I think where this is interesting to me is you kind of see this cycle where firms go, hey, we're going to build our own stuff, we're going to use vendor stuff. And this is kind of a hybrid approach where if firms have their own inbuilt Tickerplants, then you can just drop these cards in, get the benefit of doing the market data processing without having to rewrite how all of your clients do business.
No, that's a fair point. There's a lot of firms that didn't wait for us to invent the market data protocol, so they had their own protocol. So the whole idea was to make sure that we could just have a drop in and then still have their own logic, things that are proprietary to their trading, and not have any interference with it.
Oh, yeah, that's pretty cool.
And so if we look at this diagram, and we'll see right after the comparison of the first architecture that we presented today, you can see that a lot of the processing is on the FPGA. As I mentioned, decoding, normalization, lane arbitration, the book building, and then the data distribution. Our solution is able to distribute over PCIe and over Ethernet at the same time. So again, it's about making sure that you can do more with what you have. Just one FPGA card can feed tens of servers with the fully processed and filtered feed.
And so am I right in thinking everything in orange here is all done in FPGA?
Yes.
Oh, wow.
And so, yeah, coming back to the first diagram that we had, where in 2001, you basically had one server to do each of those steps. Here, we really pushed everything within the FPGA, and then you have the customer application that runs on the CPU, but again, it's just handed over fully processed market data.
So we're going from the difference of multiple sites, multiple different software hops through multiple different servers into, hey, this is all on a single card passed over to your application on the same server.
Yeah, it's just on the wire, just on the way for the data to go to your application. We just make sure to process everything and hand it over fully digested.
Cool. All right, rolling forward to 2018 then, and we had the NES Classic here, which was kind of a traditional old gaming system. But the interesting thing is, it's kind of the same kind of message that we've been saying the whole way through this, which is what is old became new again. This thing sold out everywhere. Everyone was trying to get their hands on one because everyone was a little bit nostalgic. And I think the same thing kind of happens with market data, in that we've kind of looped back and what we're trying to do hasn't changed over the years, but just the ways of achieving it and getting into a smaller form factor has.
And so for us at that time, also there were new FPGA coming around with 3 times the available logic. So we were able to push the concept of using the FPGA to accelerate the processing of your trading application even more by adding an execution gateway directly, an execution engine directly within the FPGA. So where before you maybe had the FPGA processing the market data, hand it over to the software, and then you would just go to a normal network card. Here we just add more processing on the execution stack as well.
What's interesting here, I think, is when you look back at the old architectures, it was all about, hey, it was blinkers on, only think about market data. Now what we're looking at here is, okay, how do you optimize that full path? How do you look at making sure the market data messages are optimized in a way to make a quick trading decision, and then pass that back out of the order execution engine. So I think this is going to be the way forward.
Yeah, but also there's we've had for a while cut-through mentality, where you strip everything off for latency. FPGAs today have such capacity that you can do both. You can have a very quick fast pass, but you can still maintain the level of features and functionality that people have been used to on the software. So you can have like kind of a two-speed approach with just one FPGA card on the server.
Wow, that's pretty cool.
And so yeah, what I was talking about is like if you look at on the middle, that's the FPGA. You're going to have three main components. You're going to have a feed handler, you're going to have an execution engine, and in the middle you're going to be able to drop in trading logic directly within the FPGA. And as I mentioned, you have a two-speed approach. You can still have trading logic running on the software. It's going to be less latency sensitive, but you can have higher level of functionality, and you can very easily plug in application that you already have in production today.
Interesting, and again, as you said before, this is all on a single card, so this is not huge infrastructure appliance type stuff. It's a single card popped in that does all of this.
Yeah, and you can use that card and deploy it wherever it matters. You have your server, you deploy it where it matters.
I thought worth also wrapping up with kind of some stats that we've seen from, this is NASDAQ on 20th of February 2020, mid-coronavirus world going a little bit crazy. And we're, you're seeing packet rates here over a millisecond window of over 266,000. And I think across all of the equity markets around the same time, we were seeing 44 million messages a second. So, rates are going to continue to go up, and the technology is going to continue to improve to be there. But at this point, I guess the Enyx hardware has no problem with any of this, right?
No, it doesn't. And as you mentioned, like we've seen over the presentation that the trend is the fact that the market data volumes are going up. It's not going to stop. You have new venues coming online with MEMX, and you also have like the tick size that's diminishing on pretty much every feed, which just increase the amount of data that those systems will have to crunch. And FPGAs are really tailored for that. Okay,
and now we've just got up to 2021. If you have any other questions, feel free to hit up our website, info.enx.com, scan the QR code, or Laurent and I'll be at the booth for the rest of today and tomorrow. So also tune in for our session tomorrow on nxAccess and 4 easy steps to move your trading application from software to hardware. So thank you for your time, guys.
Thank you.